So the first one here, proving this identity, as far as our strategies go, this one is really looking at the build the other side strategy or the conjugate strategy, but I find that the build the other side strategy is the one that is the easiest for people to see in this one. So both sides are already a single fraction. Both sides are already in sine and cos. So as far as our main strategies go, they're all used up, and they're not the same. So what the build the other side strategy looks at is says, well, if I make my denominators the same, and sometimes you can make the numerators the same. If I make something the same on both sides, then maybe that will help me figure out the rest of the problem. So, for example, on this one, if I'm making the denominators the same, this side would need to be multiplied by sine theta over sine theta. This side would need to be multiplied by 1 plus cos theta and 1 plus cos theta. And the reason why this could be a conjugate strategy is because 1 plus cos theta is the conjugate for 1 minus cos theta. But that's harder to see. The build the other side strategy, I think, is easier to see, and at this point, on both sides, and you don't even have to multiply this out, and if you did, it's not wrong, but I'll just leave it factored. Our denominators are the same. Now on the right-hand side, the top is sine squared theta. On the left-hand side, you've got 1 plus cos times 1 minus cos. You might recognize that as a difference of squares. If you expanded that, multiplied it out, you would get 1 minus cos squared. And now your job is to try to get our numerators the same. That's not too bad. 1 minus cos squared is sine squared. And so we've proven it. For part B, part B has a 2 in it, a big 2, not just a little 2 for the squared. Somehow when you put a big 2 in a proof question, I don't know why, but it gets harder. So I don't know if 2s are scarier, I'm not sure. So what do we do? First of all, a common mistake is if I'm working on the right-hand side and I want to change it to sine squared, I'm going to ask you which of these is correct. When I change cosecant squared, because cosecant is 1 over sine, should I write this as 2 over sine squared, or should I write this as 1 over 2 sine squared? What happens with that 2? Okay? So perfect, what I'm hearing right now is a good mix of both answers are right. Some people think the first one, some people think the second one. So you can see the reason I'm pointing this out is it is a common mistake, one of those two. If you think about an extra step before you go to either one of these, is if cosecant squared is 1 over sine squared, what does that 2 out in front do? Should it multiply both of them? Should it just multiply the bottom? Should it just multiply the top? It's really just 2 over 1, so how do we multiply fractions? Multiply the top, multiply the bottom, so we can see that that 2 doesn't go down with the sign. The 2 stays out in front. So I can erase this part, and I know that 2 cosecant squared is 2 over sine squared. Okay, so my right-hand side is a single fraction in terms of sine and cos. My left-hand side is not a single fraction in terms of sine and cos. And we don't have a common denominator. So I need to get a common denominator. What does that mean? That means that this one needs to be multiplied by 1 plus cos theta and 1 plus cos theta, and this one by 1 minus cos theta and 1 minus cos theta. Can you see that your bottom would be a difference of squares? And if you multiply that out, you would get 1 minus cos squared. And on the top, when you add them, I would now have 1 plus cos theta plus 1 minus cos theta. The 1 plus 1 will give you 2. The cos thetas will go away. And what is 1 minus cos squared? Sine squared. So again, once you get a single fraction on both sides, usually your next steps become fairly obvious. And if they don't become fairly obvious and you get stuck, you probably either need to build the other side or factor. Okay, the questions for this one, just 12a.